Welcome to lesson 1.1, part 2. We're going to start with example 3 where we left off on Monday. So let's get to it. The first question is, for what intervals is f of x equal to x squared minus 9 positive? For what intervals is the function negative? Positive and negative in this case are referring to the y value. So and the intervals are referring to the x values. So what I mean by that, well, let's take a look at the solution here. If we're looking at the graph, the positive values are when this curve is above the x-axis. It's negative when it's below. And then the intervals would be referring to the x values where that's true. So if I click positive here, it turns blue where it's positive, so the parts that are above. So the intervals would be negative infinity to negative 3. So all the way to the left, and then it stops here at negative 3, and then also 3 to infinity going right. I click off of that and show negative, it's the red part underneath. All right, so it's everywhere between negative 3 and 3. Notice how for both of these, we're using parentheses and not the bracket, because we're not including negative 3 and 3, because very specifically at negative 3 and 3 for the x values, the y value is 0, and it's neither positive or negative. Okay, so you try it. I would suggest pausing it and then clicking play again when you want to check your answer. And you can also check your answer in the text here. All right, so I would pause now. Okay, so what I would do is graph. I think that's the easiest thing to do. So I'm going to use my calculator, clear out what's there, and enter a new equation. In this case, for 3a, it's h of x, same thing as saying y equals 2x plus 10. So 2x plus 10. And then we're going to graph that. So what I can see is above the x-axis is from, let's see, 1, 2, 3, 4, 5. 5 and to the right, it's below 5 and to the left. So if I were to write those intervals, they would be 5 comma infinity for the positive part, and then negative infinity comma 5 for the negative part. We're going to check answers. I can see that that's true. Let's move to the next question. So essentially, it's the same question, just with a quadratic function now. Again, we haven't really done much with quadratics, so all I would expect you to do with a question at this point is to graph it and then just see, again, this is only asking for negative, so we'll see where it's negative. So I'm going to graph that function, figure out what's in here. So you've got negative x squared plus 1. Oh, I'm sorry. It is asking for both positive and negative. So for positive, looks like it's between negative 1 and 1. And then for negative, it would be negative infinity to negative 1, and then 1 to infinity. Okay. And again, that's what we're seeing here. It's positive where it's blue, and that would be negative 1 to 1, and then it is negative from negative infinity to negative 1, and then 1 to infinity. All right, let's move on to example 4. All right, so now we're talking about increasing and decreasing. So it's not about where it is in relation to the x-axis. It's in terms of where is it increasing, where is it decreasing. So like where is it going up and where is it going down? So let's look at this. So an absolute value function, the reason why this is upside down is because we are subtracting the absolute value. So it's as if it's negative. It is increasing on this side. So from negative infinity all the way up to 0, it is considered increasing. And then it is decreasing from 0 all the way to. Okay, so the first half is increasing, the second half is decreasing. We're not even talking about where it is positive or negative in terms of the x-axis. We're just talking about where's it going up, where's it going down. And then specifically with an absolute value function, it's going to have a maximum or a minimum. In this case, it has a maximum because the whole thing is opening down. So there is a point at the top. The vertex is at the top. If it was a standard absolute value function and it was opening up, then it would have a bottom, so it would have a minimum. All right, so the point at which a function changes from increasing to decreasing is called maximum. The point at which a function changes from decreasing to increasing is called a minimum. Both of those would be in reference to moving left to right. Okay. Again, in this case, it's a maximum. An absolute value function is going to have one or the other, not both. Again, it's a you try it question, so you pause now, give it a try, and then hit play to see the answer. Okay. I would, same thing we did with the last one. If we're talking about increasing or decreasing, or if we're talking about like the example 3, where we're just looking at positive or negative, I'm going to graph it, especially because quadratic function at this point, again, we haven't done a unit on quadratics. There's a lot of things you can do with quadratics that we just haven't learned yet. So just graph it and look at it. That's all we're doing right now. So it's x squared minus 4x. Here's what I'm going to do. Instead of retyping everything, I can, instead of hitting clear and clearing the whole thing out, I'm going to delete the negative sign. I'm going to move the cursor over. And instead of plus, it's minus. I can just override that. And then it's minus 4x. I'm just going to override that. So again, you can just type over things if that's faster. I find it faster sometimes. We'll graph. Okay. So for what values of x is the function increasing? Well, it's increasing from wherever the vertex is. So that's the inflection point. It's going down until you get to here, and then it's going back up. I'm just going to assume it's at 2, an x value of 2. I don't care how far it went down. I care at what x value did it start increasing. So I'm going to say it's at 2. All right, so the ordered pair would be, for increasing, I'm going to say 2 to infinity. All right, so 2 comma infinity. And again, I'm using parentheses because the point at the vertex, it's not increasing or decreasing. So if the vertex is at an x value of 2, I'm putting parentheses around that because I'm not including the 2 in that interval. All right, let's check. I'm sorry. I didn't actually answer the decreasing part. Let's just look at the graph quickly. And then it would be decreasing from negative infinity all the way down to 2 as well. Okay, I just didn't type that in. Luckily, these are just notes, and I'm not going to lose points for that. Okay. Let's look at part B. Same deal. It's an equation. I'm going to type it in. So it's negative 2x minus 3. clear that out. When it's a negative, again, I'm using this button, not the subtraction button. So 2x minus 3. I'm going to hit graph. Okay. The entire graph, it's a line, right? So lines are either going to be increasing the whole way, decreasing the whole way, or they are horizontal, which would be constant, or vertical, which would be neither. In this case, it's the slope is negative, so it's a decreasing. So for this one, I would say um, the function is never increasing, and it is decreasing for all values of x. Okay, so let's say increasing. Oh, that's why I'm a math teacher. Right, increasing, we would say never. Decreasing, all real numbers, all real values of x. So yeah, the interval would be negative infinity to infinity if you want to say all real numbers. If you want to use interval notation, all right, but all real numbers means the same thing. Okay. Let's look at example 5. Example 5 is talking about average rate of change for a function over a specific interval. Average rate of change is really going to refer to the change in y over the change in x. So let's take a look at this example. So the first thing you're going to look at, so if we're talking about the interval from A to B, the first thing you're going to do is figure out what are the order pairs. So if it's asking for x values of A and B, you need to figure out what is f of A, which would be like your y value. So the next thing you're going to figure out is what's the total change. So that's just the change in the y value of the b function compared to the change in the function, the value of the a function. The interval length is the difference between the x value for the b and the x value for the a. And your average rate of change is just going to be the change in the y over the change in the x. And that would end up being that purple line there. This is going to make more sense when we actually use real numbers, I promise. All right. So what do the average rates of change over the intervals -2 to 0, 0 to 3, and -2 to 3 indicate about the given functions? Okay, so let's look at the first one. The first function is just f of x equals 1. So it's just y equals 1. It's a horizontal line. So you've got your points -2, 1, 0, 1, and 3, 1. All the y values are 1 because it's f of x equals 1. So for -2 to 0, for that first interval, from -2 to 0, the slope is 0 because it's a horizontal line. From 0 to 3, so from here to here, the change is 0. All right, the slope is 0. Essentially, that's all you're doing. It's change in y over change in x. All right, and then from -2 to 3 for the entire thing, it is still 0. The slope is still 0. So f of x equals 1 has the same rate of change, 0, over every interval. This means it is a constant function. Okay. Let's look at g of x. This is g of x is equal to 1/2 x minus 1. It's a line, okay, but it has a slope to it. So from -2 to 0, you've got change in y over change in x, and the slope is 1/2. Okay? From 0 to 3, again, change in y over change in x, the slope is 1/2. From -2 to 3, the change in y over the change in x is also 1/2. So that function has a constant rate of change, and it is 1/2. So that means it's a linear function. Right? Linear functions have a constant rate of change, and that constant rate of change is the slope. You could have figured that out just by looking at the equation, by the way, because the coefficient of x is going to be your slope. Let's look at this. This is a quadratic function. H of x is equal to x squared. So the average rate of change between -2 and 0, again, change in y over change in x, is -2. The average rate of change from 0 to 3, change in y over change in x, is 3. And then from -2 to 3, the change is 1. So h of x equals x squared does not have a constant rate of change, and this means it's not a line. It's not a linear function. All right, so at this point, I would pause it, give it a try. By giving it a try, I mean figure out what's the constant rate of change, what's the rate of change over the 3 intervals, okay? So try that, and then determine if it's a linear function or not. All right, so pause now. Okay, so let's do it interval by interval. I'm going to write on the screen here. So from -2 to 0, we first need to figure out what are the y values. So when x is -2, what's the y value? We're going to substitute -2 into the function. So y is equal to the absolute value of -2, because -2 is the x value. We're figuring out what the y value is. Absolute value of -2 is 2. 2 plus 2 is 4. All right, so you've got the ordered pair -2, 4. Now we need to figure out what is the ordered pair where x is 0. We're going to do the same thing. So y is equal to the absolute value of 0 plus 2. Absolute value of 0 is 0, so y is equal to 2. So the ordered pair would be 0, 2. So the rate of change is going to be, the average rate of change is going to be the change in y. So 2 minus 4 over 0 minus -2, so 0 plus 2. Okay, and then that equals -2 over 2, which is -1. Okay, I'm going to do the same thing from 0 to 3. Well, we already know the ordered pair at 0, so now we just need to figure out what is the ordered pair at 3. So when x is 3, what's the y value? I'm going to substitute 3 in for x like we have before. So y is equal to the absolute value of 3 plus 2. Absolute value of 3 is 3, and 3 plus 2 is 5. So the ordered pair would be 5. So again, this answer was from -2 to 0. The second one's going to be from 0 to 3. So from 0 to 3 is we're talking about this point and this point. So 5 minus 2 over 3 minus 0. So you end up with 3 over 3 which is 1. So at this point, I already know they're different. So I know this isn't a line. Well, I kind of knew it wasn't a line because it was an absolute value function. Um, but there, that confirms it. And last one is asking me to find the average rate of change between -2 and 3. So that would be this point and this point. So it's going to be 5 minus 4, change in y, over change in x, 3 minus -2. So 3 is 2. So you end up with 1 over 5, 1/5. Um, so what does it indicate about the function? It's nonlinear. Okay, so since the rate of change changes over the 3 intervals, that equation is a nonlinear function. Okay. Now we have a concept summary. All right, so we're looking at 4 different kinds of functions here. First is a linear function. It's a line. The domain and range are all real numbers. Specifically, y equals x is increasing the entire way, and they have intercepts at the zeros. It crosses through the origin. Y equals x squared is considered a quadratic function. Its domain, the x values can be anything, so the domain is all real numbers. The range goes from 0 and up. It's increasing for the second half, and it's decreasing for the first half from left to right. And this one also crosses through the origin, so the intercepts are both 0. Y equals absolute value of x. Similar in a lot of ways to the y equals x squared. Domain, all real numbers. Range, 0 and up. It's increasing for the second half. It's decreasing for the first half. And the intercepts are both 0 because it goes through the origin. Y equals 1 is considered a constant function. Its domain, the x can be anything, and the range is simply 1. The y value has to be 1. There is no x-intercept. It does not cross the x-axis, and the y-intercept is 1 because, again, all the y's are 1. Okay, so I want you to try each of the do you understand questions. So again, I would pause it now and then click back and see how I answer it. Okay, so how do graphs and equations reveal information about a relationship between two quantities? All right, so the domain and range of a function give information about all the possible inputs and outputs for the relationship. The x and y intercepts of the function's graph give information about what happens to the relationship when one of the quantities is 0. The graph also shows whether the quantities in the relationship are positive or negative, whether one is increasing or decreasing with respect to the other, and what that rate of what the rate of that increase or decrease is. Right? So a graph is truly a reflection of the function, right? It's a visual reflection of the function. Okay, I would pause it now, see what you think, and then check back. All right, define the term 0 of a function in your own words. The zeros of a function are the input values that result in a function output value of 0. You could also have said, and been 100% correct, if you said they are the x-intercepts. an even more basic way to say it would be it's where the function crosses the x-axis on the graph. All of that would have been fine. And one more. Again, pause it and click back when you have a good answer. All right, Lonzel said the function shown in the graph is positive on the interval -1 to 5 and negative on the interval -5 to 1. Identify and correct Lonzel's error. All right, so he's saying from -1 to 5, it's positive. From -1 to 5, it's not positive, it's increasing. All right, it's actually negative for a portion of that interval. All right, so Lonzel is confusing the term positive and increasing. And then same thing for negative. He's saying it's negative from -5 to -1, when in fact it's decreasing. So again, he's also um, confusing the term negative and decreasing. All right, so that's basically what he just said. The function is positive from -infinity to -4, and then 2 to infinity, and then it's negative in between. Again, I would pause it and then give it a try. All right, domain. In this case, it's all the x values, right? So it starts at -4 and it goes to 4. However, the one part that you should, there you go. There we go. Notice how it's an open circle at -4 and a closed circle at 4. So that just means when I go to write the function, I have parentheses on the left side at -4. And I have a bracket after the 4. So open circle, parentheses, close circle, bracket. Okay. And there we go. Find the range. Well, it goes from the bottom, -1 of a y value, and the top would be a y value of 3. They're neither open circle or closed circles, so it's implied a closed circle on a line like that, right? So there's really no difference between a closed circle like that and then just the line. The only thing that would be different is if it had an open circle there. So it will be brackets for both. So -1 on the bottom, 3 on the top, and again closed with brackets the entire way. Okay, next one. The x-intercepts, right? Everywhere it crosses the x-axis. So -3, -1, 4. And we're making an ordered pair, so I'm using parentheses. So it's -3, 0. -1, 0. And 4, 0. They gave them just as the values. Totally fine. Again, when we get to the practice, like personally, I don't care if it was paper and pencil. When we talk about how to answer the questions in the practice, it will give you specific instructions of whether it just wants a number, whether it wants the ordered pair. So that'll be something to keep in mind. All right, the y-intercepts, intercept or septs, in this case it's just 1. It's only crossing the y-axis at one point, and it's at 1. All right, so I learned my lesson from the last one. I'm just going to say y equals 1. Intercept is y equals 1. Okay. Find the intervals where the graph is positive. So it's positive where the graph is above the x-axis. So there's one little part of an interval here. So -4 to -3. I'm using parentheses on that one. On the left for the -4 because it's an open circle. So -4 and then to -3. Again, it would only be parentheses if it's an open circle. So even though it's not a closed circle, the line implies that it counts on that line. So -3. Actually, no. On the line would be 0. So it will be parentheses. Okay. And then it will be, because it doesn't even matter if it's open circle or closed circle. It's not positive on the line. It's where x is 0. 0 is not positive. So I apologize for that. I'm sorry, the y is 0. So it's not positive. The second part would be from -1 all the way over to 4. So I'm just going to use parentheses. -1, comma 4. All right, let's check that out. So -4 to -3, and then -1 to 4. We're good. I'm guessing they're going to ask negative on the next one. What do you think? Decreasing. Oh well, I guessed wrong. Okay, so the interval where it's decreasing, so it's where it's going down. It is decreasing from -4 to -2. So just where is the graph going down? What are the x values where it's going down? -4 to -2, and then from 2 to 4. All right. Again, both those were going to be parentheses because like the little vertex points there, it's neither increasing or decreasing, so you can't include it. All right. So again, the first one is -4, -2. And then 2, 4. Let me close it off. Okay. Now we get increasing. It's only increasing on that middle section there. So like, where's the graph going up? What are the x values when the graph is going up? So it's from -2, an x value of -2, all the way to an x value of 2. And again, it will be parentheses because we are not including the -2 and the 2. Okay. And then find the rate of change from -1 to 4. So, and again, these are two ordered pairs. It's only talking about the x values there. So I've got two ordered pairs where one of the x values is -1, the other x value is 4. Okay. Where x is -1, y value is 0. It's that point there. And when x is 4, the y value is also 0. So then the average rate of change is the slope between those 2 points. So it's a change in y So 0 minus 0 over the change in x. So 4 minus negative 1. So 4 plus 1, which is 5. So you get 0 over 5. 0 divided by anything is 0. So the rate of change between over that interval, right, from negative 1 to 4 is 0. Okay, so the rate of change there is 0. Okay. The next thing on our list is the Math Excel practice, and that's what we're going to do, what you're going to do for practice starting on Wednesday. And we'll start class Wednesday, and I'll kind of walk you through how some of that looks, and what to do. And then I'm just going to give you class time on Wednesday to get started with that. Um, so that's it. So at this point in your notes, if there's a place where you hit submit, I think there is, do that. So that way on my end, I can see that you completed the notes. Otherwise, that's it. And I will see you in class on Wednesday.